7.3 is multiplying powers with the same base. And we start out with what's 3 to the fourth times 3 to the second written only using one exponent. So let's talk about 3 to the fourth. 3 to the fourth is 3 times 3 times 3 times 3. That's 3 to the fourth. And 3 to the second is 3 times 3. So we can rewrite this as 3 to the 1, 2, 3, 4, 5, 6. 3 to the sixth. So 3 to the fourth means we have 3 4 different times. 3 to the second means we have 3 2 different times. So altogether we have 3 6 times. So 3 to the sixth. Let's do another one. What is 4 to the third times 4 to the fifth? Only using one exponent. Again, 4 to the third. 4 times 4 times 4 times 4 to the fifth, which is 4 times 4 times 4 times 4 times 4. 1, 2, 3, 4, 5, 6, 7, 8. Altogether, we have 4 to the eighth. Let's do another one. 0.5 to the fourth times 0.5 to the seventh. And we'll write them out again. So we have 0.5 times, I'm going to put them in parentheses so we can tell what's decimals and what's multiplication. That's 0.5 to the fourth. And then we have it times 0.5 to the seventh. Boy, that's a lot of 0.5s. 2, 3, 4, 5, 6, 7. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 0.5 to the 11th. Now you might notice something that's happening here. We can draw out all those 5s or 0.5s or 4s or whatever it was every time. But if you notice, that is 4 of them here and 7 of them here. So if we add 4 and 7 up, we get 11. So it's really 0.5 to the 11th because we have 11 between the two. So what's x to the second times x to the fourth with only one exponent? X to the second. X to the fourth would be x to the fourth plus 2 more, x to the sixth. So, rule, when we have a to the m times a to the n, the basic rule is you're going to end up with a to the m plus n. We add up all the a's that we have, and we have m in the first bunch and n in the second bunch, so it's a to the m plus n. So, to multiply powers with the same base, we're going to add the exponents. What's the base? The base has to be the same. The base is, like here, the base is 2. Here are bases, a. Here are base 0.4. So we are going to add the exponents when we're multiplying. So 2 times 2. I don't multiply the 2's out. That's just 2. 3 times here and 4 more times there. So it's 7 times, which would be 2 times 2 times 2 times 2 times 2 times 2 times 2, which we can write out. That's great if that's the easiest way for you to do it. Here we have a to the negative third. We know that that needs to get moved. Let's talk about that actually a different time because that's more in the division and we haven't talked about that. If we're just going to multiply them using the rules that we have above, it says you add the exponents. So it would be a to the negative third plus 5. Negative 3 plus 5 is 2, so this is a to the second. Next one, 0.4 to the negative 3 times 0.4 to the negative 8th. I am going to move those. We have 1. My 0.4 to the negative 3 moves to the denominator and changes to the third. And then my 0.4 to the negative 8th, 0.4 moves to the denominator, and the negative 8 changes to 8. I have 1 over there's 3 4s right here and 8 more there, excuse me, 0.4s. So I have 0.4 to the 8th, 9th, 10th, 11th. So I add up all of the 0.4s that I have and I have 0.4 to the 11th. Here's why it's kind of nice to learn the rule instead of having to draw out all the x's or the y's or the 4s or whatever, because now we have 4 to the 32nd. That's a lot of 4s times 4 to the 25th. But I know I just need to gather them up. 4 to the 32nd means I have 32 different times I have 4. So I have 4 times 4 times 4 times 4, 32 times. So it's 4 to the 32nd plus 25th. We're going to add the exponents. So 32 and 25 would be 4 to the 57th. That's a really big number. All right, -5 to the -2nd. We haven't learned division rules yet, so I'm not going to worry about those. But we did learn we can add the exponents if the bases are the same, and our bases are both -5. So I have -5 in parentheses still, to the parentheses -2 plus 7. Yeah, I should have these in parentheses, I'm sorry, because otherwise you don't know what we're doing, but that's in parentheses. So it would be -5 to the -2 plus 7 is 5th. So -5 in parentheses to the 5th. We could plug that into the calculator. Think about that. Is that going to be a negative number or a positive number? And it should be a negative, because I'm taking -5 5 different times, so it's going to be a negative. So -5 to the 5th is actually -3,125. So simplifying and multiplying algebraic expressions, and it says leave no negative exponents in your answer. Sorry, I couldn't get that out. So here's where I tell kids numbers times numbers, variables times variables. So I can rewrite this. Multiplication can be done in any order. We've learned that before. So I'm going to write my numbers times my numbers right next to each other. So I got those taken care of. Then I have z to the 5th and z to the -12th. And because we are just talking about multiplication to begin with, so 9 times 4 is 36. And it would be z to the 5 minus 12, or 5 plus a -12, which is 36 z to the -7th. And it said no negative exponents in our answer. And remember, the only thing raised to the -7th is actually that z. 36 is, there's nothing, it's raised to nothing. It just says 36. 36. But the z I have to move and lose. So I move it to the denominator. And I change the -7 to a +7. So my answer is 36 divided by z to the 7th. Again, I'm going to rearrange. I'm going to put all my numbers together. So I have 2 times 9 times -3. And then let's see, I'm going to put my a's together. So I have a right here times a squared. And then the only other thing we have is b to the 4th. Let's do some simplification. 2 times 9 is 18. Times -3 is -54. So I have my numbers taken care of. That's all that part. This is a to the 1st times a to the 2nd. Sorry, my 54 doesn't look very good. -54. A to the 1st times a to the 2nd is a to the 3rd, or 1 plus 2, b to the 4th. And that is all I can do to simplify that. And sometimes kids are tempted to move that -54 to the denominator because they see the negative, but it is not a negative exponent. It's just a negative number. Negative numbers are fine. We don't have to do anything with them. They're perfectly okay to have. All right, so again, simplify. Let's see, I have some numbers. I'm going to rearrange. It's all multiplication, so it's 5 times 3. And then let's put our x's together. X to the 4th. X to the -9th, and I'm going to write the x as x to the 1st power. So 5 times 3, 15, that's the easy part, right? We're done with that. So we have x to the parenthesis 4 plus a negative 9 or minus 9 plus 1. So x to the 4 minus 9 plus 1. 4 minus 9 should be negative 5 plus 1 is negative 4. So I have 15 x to the negative 4th. And again, I can't have a negative exponent in my answer, so I have to do something with that. But remember, the negative exponent only goes to the x. 15 just stays where it is. And I move to the denominator and I lose my negative. So that would be my answer, 15 over x to the 4th. X to the a times x to the b times x to the c is x to the a plus b plus c. I don't know what a, b, and c are. I can't do anything to simplify that. I think I'm done with that one. All right, simplify this, leave no negative exponents again. P plus 1 to the negative 4th. I'm going to write a fraction bar. I'm going to put 1 here. And I'm going to write t plus 1 to the 4th. I moved it to the denominator. I lost a negative sign. Now let's look at this part. And again, that whole thing is raised to a negative 3, so I need to move it to the denominator as t plus 1 to the 3rd. Now, I have some bases that are the same, the 1 in the numerator. This t plus 1 is the same in both of them, so I'm going to write t plus 1. And then we have to the 4 plus 3, which equals 1 over t plus 1 to the 7th. Same base, so I can add them up. All right. This one, 3, not doing anything to the 3, it just stays a 3. This, all right, I want to move ahead and give you the next bit of information, but in this I'm not supposed to. So let's just look at this. It would be a to the 1 times a to the negative 8th, which equals 3 over a to the 1 minus 8, which is 3 over a to the negative 7th. Again, I can't have a negative exponent, so I have to move it. This time it's in the denominator, so I move it to the numerator. So you'd get 3a to the 7th. And that would be the answer. Let's see. We have another problem that I think is this section, and then we have a review one. But here, numbers times numbers, negative 4 times 7, which, and then c to the 3rd times c to the negative 2nd. We can, yeah, so negative 4 times 7 is negative 28. That's just a number. It's a negative number. I don't need to move it because that's fine. I just can't have negative exponents. C to the 3 minus 2. So negative 28 c. 3 minus 2 is just 1, so c to the 1st, which is just c. So negative 28c. Scientific notation, we haven't talked much about multiplying it. But again, I always just do the leading number times the leading number. So 3 times 5, because we can do it in any order. And then times 10 to the 5th times 10 to the negative 12th. 3 times 5, 15. I'm going to use x as a multiplication symbol now again to put it back in scientific notation. But this is just 10 to the 5 minus 12 or 5 plus negative 12. So that is 15 times 10 to the negative 7. And since it's scientific notation, negative exponents are fine. That just means I'm going to have a very small number. So this would be my answer, 15 times 10 to the negative 7th. This is a long one. All right, so let's try another one. 8 times 7 times 10 to the negative 7th times 10 to the negative 3rd. 8 times 7, 56. 10 to the negative, times 10 to the negative 7 plus or minus, let's see, plus a negative 3 which is 56 times 10 to the negative 10th. You go ahead and finish these two. This is a different kind of example. It's one where we're actually talking about geometry and we're trying to find the area of a square. And it says the area of the square is base times height. And it gives us the base is 4AB. And the height is also going to be 4AB because it's a square, so the sides are the same. So I just need to know what 4AB times 4AB is. Again, number times number, 4 times 4, 16. Oh, my smartboard's going crazy, so let's give it a try here. Hopefully it'll hold out. A times A, B times B, and we have 16, well, let's try this again, 16, A to the first, so A to the second, B to the first, B to the first, B to the second. Find the volume of a rectangular solid with the dimensions 3xy by 2x squared by 5y. I thought that was a b in there. So volume is length. She has LBH, but it's multiplying the three dimensions together of a rectangular solid. So our dimensions are 3xy times 2x squared times 5y. Numbers times numbers. Line those up. 3 times 2 times 5. Let's look at our x's. I have x to the first, then x to the second. And let's look at our y's. I have y to the first and another y to the first. So 3 times 2 is 6 times 5, 30. X to the first times x to the second is x to the third. Y to the first times y to the first is y to the second. And it would be units cubed, actually, because it is a volume. I think we will be done with it here. Sorry this video went so long, but hopefully it will help you out in class.